Welcome. In this workshop, we are going to set up execution events on a modern node. Execution events give you the fastest possible access to blockchain data through shared memory, much faster than a JSON RPC or WebSockets. Before we start, you'll need a running Monad full node and SSH access to it. If you don't have a node yet, check out the full node installation guide first. Alright, let's get started. Step 1 is installing the packages we need. The main one is Huge ADM, which manages huge pages. These are large memory pages that give us better performance for shared memory communication. So I'll copy this command here and paste it into my terminal, which is connected to my bare metal server with the Monad full node running on it. Then, if you want to write your own applications that consume execution events, you'll also need these development libraries, headers, and ZSTD compression library. I'll copy the command and paste it and click enter. Alright, step 2 is setting up the Huge TLBFS mount. This is a special file system that gives us access to huge pages. We'll create a systemd service so it persists across reboots. Let's open Nano to create the service file. I'll copy the command here and run it. Then I will copy these contents and then Ctrl O, enter, and then Ctrl X to exit Nano. So let's go down. If at any point in the guide you wonder what the commands that we are running or what the code we are pasting around is doing, you can check the behind the scenes notes here. These will help you understand what's going on better. Then I will enable and restart the services. The -- now flag here means that it will start immediately, not just on the next boot. Step 3 is quick. We just need to create a directory where the execution daemon will write the event ring files and set the ownership so our user can write to it. Then I'll copy the command, paste it here, and let's move on to the next step. Alright, step 4 is the most important one. We need to configure the execution daemon to actually output events to our shared memory ring buffer. We use systemctl edit to create an override file. This is safer than editing the original service file because it won't get overwritten during updates. So to open the override editor, I'll copy the command and click enter here. Then I will add the following configuration. The key part is the -- exec - event - ring flag, which tells the daemon where to write the event ring file. Note that we need 2 exec start lines. The first empty one clears the default, and the second sets our custom comment. Now I will save the file with Ctrl O, enter, then I will use Ctrl X to exit Nano. Let's go down. Now we need to reload systemd again and restart the execution daemon. After this, it will start writing execution events to the shared memory ring buffer. Now let's move on to step 5. Step 5 configures the RPC daemon to enable WebSocket support. This lets you use eth_subscribe to get real-time updates. And one important thing here, RPC with WebSocket has a dependency on execution running with events enabled. If you skip step 4, your RPC will crash. So let's open the override editor again. And I'll copy the contents here and paste them. So the key flags here are exec event path, which points to the same event ring file that execution writes to, and VS enabled, which turns on WebSocket support on port 8081. Then I will click Ctrl O, enter to write, and Ctrl X to exit Nano. Let's move on and reload systemd and restart the RPC. Now we have WebSocket support enabled. Alright, it's time to verify the setup. Let's verify that everything is working. First, we check if the event ring file was created. And I think it's ready for us to consume. Let's move on. Now let's check the execution daemon status, and hopefully, yes, we are seeing all green here. Let's move on. Let's check the WebSocket connectivity now. Now you can test it in other ways, but I'll be using WebSocket, and you can install it with cargo install WebSocket. Since I already have it installed, I'll just copy this command here and paste it. And hopefully we will be able to get to this view in which we will be able to paste this command and subscribe to Neve-Ads. Alright, this is looking beautiful. We have everything ready. Alright, this wraps the setup. Your node is now configured to output execution events via shared memory and accept WebSocket connections. From here, you can build high-performance data consumers using the C or Rust SDK, subscribe to real-time events like new blogs and pending transactions via WebSockets, or integrate this into your existing infrastructure for trading bots, indexes, or analytics pipelines. If something went wrong, here are the most common issues and how to fix them. And see you in the next workshop.